All right, continuing on Unit 4, Lesson 11. We're moving on to Problem 11.3. And what we want to do is use the expression we came up with in 11.2 to approximate the value of pi. So just a reminder, the expression for the perimeter that we came up with in 11.2 is perimeter is equal to 2 times the number of sides times the sine of 180 divided by the number of sides. So that's what we assume our perimeter will be equal to. So what we're going to do is we're going to use this to try and evaluate, to approximate the value of pi. Now, remembering that a circle has a circumference of 2 pi times the radius, and our radius, remember, our radius was equal to 1. So a circle with a circumference, or with a radius of 1, will have a circumference of 2 pi. So if our circumference is 2 pi, if we just divide this circumference by 2, we realize that pi is going to be equal to the circumference divided by 2. So if we take this perimeter and divide it by 2, we should be getting really close to pi. So let's see what happens when our approximation. Whenever we have a hexagon, so the number of sides is 6. So let's look at the perimeter. The perimeter is going to be 2 times the number of sides of 6 times sine of 180 divided by 6. Going to need a calculator for this. So 2 times 6 is 12 times the sine. 180 divided by 6 is 30. Now I can plug that directly into my calculator. 12 times the sine of a 30-degree angle, and I get a value of 6. But remember, I want to take this perimeter and I want to divide it by 2, and I get 3. And how close is that to pi? So pi is 3.14. So if we take a look here, pi, I'm drawing a blank. Pi is equal to 3.1416, call it. So pi is going to be equal to 3.1416. Okay? So how close is this? Well, it is 0.1416 off. So pretty close. Let's go down here to number 2. When the approximation, what's going to happen with our approximation when my side lengths are 10? So what I want you to realize is what's happening here is as we go through these, we are adding side lengths, which means we are getting closer and closer and closer to actually having a circle. So let's look at our perimeter. When my n value is 10, so it'll be 2 times 10 sides times the sine of 180 divided by 10. So my perimeter is going to be 20 times the sine of 180 divided by 10 is 18. Now I'm going to plug this into my calculator. 20 times the sine of 18, and it's 6.1803. If I divide this by 2, I get 3.0902. 3.0902. How far off of pi is that? Well, let's take pi and subtract that answer. And we get 0.0902 0.0514. Notice it was 0.1416, and increasing the number of sides gets it closer to pi. How about if the number of sides is 20? So the perimeter is going to be 2 times the 20 times the sine of 180 divided by 20. So the perimeter is going to be 40 times the sine. 180 divided by 20 is 9. Back to my calculator. 40 times the sine of a 9-degree angle. 40 sine 9. Divide this by 2. And I get 3.1287. 3.1287. Now I want to subtract that from pi. So pi minus that last answer I had. And I get 0.0129 off. Getting even closer. Getting even closer. What happens when the sides are 50? So my perimeter is going to be 2 times the 50 times the sine of 180 divided by 50. 100 sine of 18/5. Back to my calculator. 100 sine 18/5. I get 6.291, 6.2791. I'm going to divide that by 2. 3.1395. Remembering that I want to take pi and I want to subtract that last answer. 0.0021 off. Even closer. So what value of n approximates the value of pi to the 1,000th place? Well, as it turns out, any n value that is greater than 71 will approximate pi very, very well to the 1,000th place. Okay, so what we've done here is we've found a basic formula or a general formula for the perimeter of a regular polygon with a radius of 1 unit, and we can see that as we increase the number of sides, our value for that perimeter gets closer and closer and closer to what pi is. Okay, so pi, realistically, remember up here, what I've been doing is I've been taking this perimeter and dividing it by 2. So if I take this part of my general formula, if I divide that by 2, notice what happens is that the n goes, the 2 goes away. So I know that my pi can be approximated with n times the sine of 180 over n, as long as my radius is equal to 1. And that's kind of cool. A little bit of algebra work, working with trig, good stuff.